Ahead and get started. My name's Mike Madison, and thanks for joining me here right before lunch to talk a little bit about data pipelines for digital signage. I'm a technical architect at Acquia, and over the last year and a half, I've basically been doing all digital signs all the time. So I'm happy to get to share a little bit with you about what I've been working on. And one thing I just wanted to start out with, my background is actually not in computer science, it's in human-computer interaction. And one of the kind of funny things about a digital signage project, right, if you think about where interactions have gone in the last decade, we've been going from keyboard and mouse to touch, and now we're talking about voice. And I don't know that we're quite to like the mental interaction thing yet, but when you look at a sign, like, we're actually going completely like back-asswards in the other direction, right? There's zero interactivity with the user. You can have 1,000 people standing around looking at that sign, and it's going to show the same data to all of them, no matter what. So much of what is going to show up on a sign is entirely based on how you get the data to the sign and the business rules that you're going to sort of undertake at the sign level. That doesn't mean there's not context, but again, it's completely different from what you're going to do, say, if you're going out and building the next Facebook or the next Twitter app or whatever. So today's topic is fairly advanced in the sense that we're talking about moving large quantities of data, but I'm going to try and do this at sort of a beginner level. We're going to keep this sort of at an architectural discussion. I'm going to show you a little bit of code, but mostly we're going to be talking about sort of approach, things that have worked, things that haven't worked, things that you definitely want to avoid. And even though this is a Drupal talk, it's not really that much about Drupal. Just I'll throw that out there now. We will talk about Drupal, but this is not like how-to Drupal with digital signs. I also want to give just a quick disclaimer. We're going to be talking almost exclusively in like PHP language today, but like, pick your poison. If you want to go do a signage system using Node, if you want to go do it in your other favorite language, like the principles we're talking about here are very portable, right? You can totally do what we're talking about anywhere. The examples I have just happen to be PHP. So at a high level, the topics we're really going to drill down into today, right, are if you're building a pipeline, like, what does it do? How does it work? How might you get started? Some metrics for success, and I think this is a particularly important thing. Again, I've had a digital signage system in production for almost a year now. We've learned some hard lessons as a result of that. And we're also going to talk a bit about automated testing and doing some really slick stuff with Behat and other testing frameworks to actually interact with your pipeline. But first, let's go through a few basic definitions, right? So when I say digital sign, I am sort of pre-assuming that there is some sort of automated component to that sign, right? If you walk into Best Buy and you go back to their like video department, like, are those digital signs? No, probably not, right? That's a bunch of TVs plugged into a DVD player. That's not what I'm talking about. If you go into the airport and you see the arrivals board, that's going to update. There may be a human in the loop somewhere, but that's still largely an automated process. I've actually seen all over Portland driving around this weekend. They have a lot of digital road signs, right? How long is it going to take to get where you're going? What is the speed limit on this part of the road? Yeah, that's all digital signage. Definitely fits the bill. How do you get data to a sign, right? There's two big pieces. Either the sign is going out and pulling data, or some system, maybe a data pipeline, is pushing data out to the sign. Pulling, in my humble opinion, is a really just dangerous, terrible idea. Having said that, we totally built our prototype with a pull system. It worked fine. We had a few dozen signs, and basically what was happening was every sign, every couple of seconds, was going out and requesting new data. That scales a few dozen times, and then you start like DDoSing yourself. So you maybe don't do that. But the other big problem, if you can scale your hardware to support a polling system, is that now your sign is largely responsible for everything. right? The sign has to make the request. The sign has to get the data. The sign has to validate the data. The sign has to parse the data. The sign has to display the data. You're moving all of your business logic into the front end. Now, for the front end developers in the room, and I know there's at least one sitting back there, that might be really exciting. It works, right? It is feasibly possible, but architecturally, the more your front end is doing, the more memory your device is going to need. The more work your front end is doing, the more likely that if you look at two different signs at the same time, you're going to see different stuff on the same sign, or like signs that should be showing the same data are showing different things because they're now parsing at different speeds. So pull models, again, fun to play with. In practice, I would have avoid if at all possible. This then brings us to a push model. And the push model actually, sorry front-end developers, takes almost all of that effort out of the front end. You make a front end that's very reactionary. And all of the data modeling, all of the data logic now happens in some sort of back-end process. And the sign is just sort of receiving that data and displaying it. This is going to make your back-end developers work a lot harder. This is potentially a more complex issue. We'll talk a lot about that. But it is ultimately, I think, a lot safer. It's more performant, and you're a lot more likely to have the right data on the right sign at the right time without having all of this heavy-duty parsing in the front end. So if we're talking about a pipeline, like in my world, data pipeline is going to automatically push data. It's going to limit human interaction, right? Like we put our signage system in production like last summer and largely forgot about it. We go back and check the logs periodically to make sure it's working. We push new code to fix bugs, but I mean, it's not like somebody has to sit there and prod it periodically, right? I mean, it works. We want to streamline the data collection so that it can go out and get data, parse data, send data very, very quickly. We can parse train data for an entire city in about a second, like half a second to download it, half a second to parse it. You want that to happen very, very quickly so that you can get that data out. And then you can broadcast to multiple locations. So again, if you have multiple signs that are displaying the same data, it looks really weird if one of them is 5 minutes ahead of the other one at the other end of like a platform or something. I've talked a lot about data. I just wanted to take a moment and, like in the digital signage world, I think of two big use cases for data. The first is what I call just-in-time information. So if you walk into a building on a university campus and there's a digital sign right outside the building and the lunch menu's from 2 weeks ago, like that doesn't do you any good, right? So news and announcements should be current. Thankfully, news and announcements usually don't have to update like 3 times a minute, right? That's something you can do. It's timely data, but it's not fast, timely data. Transit data, on the other hand, like people might die if you screw that up. You know, if you're driving on the highway and it says traffic's fine, go 75 miles an hour, you go around the corner and like it's gridlocked and stopped, I mean, like that's gonna kill somebody. So transit data is not only in-time information, it has to be very timely. Our pipeline runs 15 or 20 times a minute. So, you know, getting data out to a sign is something that you should do quickly if needed. The other use case, which we're not going to focus on really at all today, I just want to mention that everything we're talking about is totally valid for this, is like a retail or a marketing model, right? So you go to Times Square, you see these giant billboards. You go into a retail store and they're not just plugging their signs into a DVD player, right? They're managing these from some sort of central hub. You can use this exact same sort of data pipeline model to provide media content, videos, images, slideshows, whatever, to these devices. And in fact, I'd go so far to say is what we're talking about here would actually work for many different kinds of systems, not just signage systems, right? I mean, if you think about, you know, how does Slack send data from, you know, one system to another? How does Facebook Messenger send from, you know, data from one system to another? A lot of the metrics that we're talking about here today are very, very similar to how those systems work. We're just, you know, specifically tuning it to digital signage. Last sort of intro slide here is just to talk about success metrics. I think the biggest one is fault tolerance. Right? So even if you're just talking about like a campus, your signs are still spread out all over the place. So if your internet goes down, the last thing you want to have to do is run around to every building on the campus and reboot every one of your signs to get it back up and running. If your data stops flowing, the last thing you want is for people calling in telling you, I don't know what's going on because the sign's down. So making sure that the sign can recover from problems, I really think is one of the very first things that you need to think about. Logging and monitoring. So you may not always think about logging when you're building like a normal website, right? Oh, the server stack will handle that, right? If something goes wrong, the PHP error logs are going to trip, and I don't know, support can deal with that. With a signage system, very frequently, your logging and monitoring system is your only clue that something's wrong, right? You don't have users logging into this system. You're not going to be logging into it yourself, most likely, right? The closest sign's 10 minutes away. Do you know if it's working? I don't. So having a logging and monitoring system that's actually going to keep track of, oh, hey, our primary data provider just went down. We haven't had anything in 10 minutes. What's going on? Help. These are architectural decisions that could sink or swim a signage system before you even get into production. Again, independence, this is something you want to largely be able to turn on and forget about. It has to be secure. When I originally was putting this success metrics list together, I had a lot of other things that were more like general signage tips. But security is something that affects the entire stack, right? If you don't require like SSL communication as part of your data acquisition process, you're begging for a man-in-the-middle attack. If you're not validating your data formats, again, you're begging for somebody to compromise your sign. And as cool as seeing something like this is, I particularly like these. You don't want to get this phone call asking what the hell's going on with the signs. So, again, security and fault tolerance are the sort of thing that you really need to plan for, because I guarantee you somebody's going to take a picture and make you look stupid if something goes wrong, when something gets wrong. And then just the last success metric here I just wanted to cover quickly is having, reliable current data. And this is going to be a theme sort of throughout this talk, that you need to know what kind of data is going to be on your sign and when it needs to be there. And everything that you do, from the time you start to the time that you deliver that data, has to fit within those time parameters. Otherwise, you're just wasting your time. So let's dive in and talk a little bit about data. And anytime you start talking about architecting a solution, right, and this isn't just with digital signs, this is with websites, this is with apps, the very first question you got to ask is, what the heck is the data? Where am I getting it? How often does it update? If I can't get to it, is there some sort of like backup strategy, right? If Twitter's down, am I just screwed, or is there like a backup URL that I can go to? Understanding the data format. So if you're pulling like data out of a Drupal website and you're using a couple of different APIs, you may have plain text, JSON in a couple of different formats, XML, whatever else. And you may have to like try to massage all of those different data sources into a single data stream that can show up on your screen. What sort of authentication do you have to handle? Hopefully there's something. Can anybody just go get this data? What do you have to do to prove that you should be able to get to it? And this is one that you may not immediately think of, but like, how big is the data dump? Right? If you need to download a 10 gig file and parse it in 5 seconds, like, you're screwed. I mean, that's just not going to happen. So again, you've got to think about how much data are you actually going to be parsing, and how quickly do you have to parse it very early on. I wouldn't be doing anybody any favors if I didn't throw this slide out there. Like, think about the display and how users are going to interact with that data. Right? If you're driving down the street and all you're ever going to show is the speed limit, that's very simple, right? You probably need to pass 2 characters through your data pipeline. If you're talking about a much more sort of robust sign, like maybe that the sign we saw on the subway platform earlier, you're sending a lot more information through. So I wanted to start with a very, very simple example of a data pipeline. So if you embed a Twitter widget on a page, that actually meets many of the criteria that we've talked about for getting data from point A to point B, right? It's going to display, it's going to show the most recent data. It will update, although you probably have to reload the page to get the update. And you know that it's going to be relatively safe data because you're pulling it directly from Twitter without anybody, sort of getting into it. It is very simple to implement, which is a pro, but I think the biggest cons are that, with something like this, you don't have any direct control over the data. And that's going to be a theme we're going to be talking about a lot here over these next few slides. If you have a sign that has multiple areas on it, you don't necessarily want to embed a weather widget from like weather.com and a Twitter widget from twitter.com and a Facebook widget. Like if you have all of these widgets, I mean, yeah, sure, you're getting data onto your sign, but it's going to look like somebody just pasted a bunch of other widgets on the screen. So you don't really have a lot of control over the presentation. And if we're talking about like our sign example, I mean, like a little LCD screen like that doesn't let you embed a widget. And I don't think whatever software is providing that speed data is going to have something you could embed anyway. So this is where you have to start thinking about the kind of solution that you actually want to architect, right? And if we have this big picture idea of I want to get data onto my sign, like we need to put something in the middle there that helps you sort of facilitate that data transfer process. And in my world, I put that into sort of three big pieces. The first thing is you need to acquire data. And talking like object-oriented PHP, we'll look at some examples here in a moment. We call that our provider class. You want to organize the data, which we call a categorizer class. And then you want to send the data, which is what we would call a sender class. So a provider class, and I in a specific example for you here. Oh, great. It actually came up. So a provider class is, and again, this is an abstract class, so this is something we'll instantiate and use later. But a provider class basically has a couple of methods in it. Get data, very, very exciting name, tries to go out and get raw data. And in this abstract class, you can actually see that the raw data function is completely empty because we completely customize that for every provider. And one of the very first things that we do in this function is catch an exception. So if we go out and try to get data and that fails, like we start screaming bloody murder immediately because signs do not work without data. Assuming that we do get data, we validate that data. And again, the data validation function here is basically worthless because you can't validate data unless you know what it's supposed to have in it. So again, we do more with that later. And that's it, right? This is a very simple little class. There's a couple of other methods here. Get type is something for logging that basically helps our logs know that if there is a problem, it's over here, not over there. We've got a setter for that class as well. But I mean, literally, that's it. Get data, get raw data, validate data. That's all that takes. And if we go look at a actual example of a provider as opposed to the abstract class, so this is our weather data provider. Like our raw data function is get message. So you can see here where we actually go and attempt to get messages out of our cache. And if there's nothing in the cache, we go get fresh message. Fresh message here, you can see it actually goes out and makes a request. I'm not going to go through every line of this, but this is not complicated PHP code, right? I mean, this is make a request. If the request is cached, get it out of the cache. If it isn't in the cache, go get fresh data, decode the JSON, and return ultimately the message. Doesn't have to be complicated code, it just has to work. Next thing is where we actually categorize the data. So very frequently, when you go out to a data provider, sometimes you actually get way more data than you really need, right? If you have hundreds of signs, there's thousands of signs, remember, you don't want to have to make a request for every single sign. You want to be able to go out and get your data, parse your data, and then send it out to the signs as appropriate. And that's where this categorizer class really comes into to play. And again, this is an abstract class. Not going to get too deep into this one, but I do want to stress that something you're not going to see anywhere in this categorization is like a for loop. There's zero looping in this class. Remember when I talked about performance, speed, if you just sit there and loop and loop and loop and loop through your data, that is certainly one way to find what you're looking for, but it's also one way to really tank your performance on your pipeline. So our categorizer is there to break up the data into smaller payloads that we can send out to the signs, and it's there to do it as quickly as possible. And you can see we basically are breaking down the keys in the data, and then we're returning a different array that has been sort of reorganized in a simpler format. And then the final piece is the sender. And for us, and we'll talk about data transmission later on in the talk, but for us, we really only send data one place. We use AWS IoT, the Internet of Things service, to send our data. But if you had different places that you use to actually provide data out or send data out to your signs, your sender class is going to handle your authentication. It's going to actually take those data payloads and send them out to the various data providers that can then get it onto the signs. And by breaking these things up into sort of these smaller object-oriented pieces, again, we can fully customize the way we get data, categorize data, sort of on a per source basis. So if we blow out that little black box, we're now actually seeing that the provider is the thing that gets the data, right? The categorizer runs, breaks apart the data, sender runs, and sends it out to the sign. And more realistically, you're probably not just getting data from one system. So again, with an object-oriented pipeline, you can have n number of providers running, each going out and getting that data. You probably would use the same categorizer for each, but you may not. So there could be different categorizers. And then again, you could have different senders running as well based on how you're actually going to get the data out to the sign. And if we go a step farther, this obviously supports many different signs. And in our case, we're running a couple thousand signs. So this pipeline can really scale and be very robust very quickly, assuming you sort of start with that growth model in mind. And just to throw it out there, we're a good 20 minutes into this conversation, and I've hardly talked about Drupal, right? And there's a lot of things that Drupal can do to enhance a data pipeline, but I really want to stress this question, and should Drupal actually be your pipeline, or even be integral in this pipeline? So I want to break for just a moment and talk about performance. So as I said earlier, our data pipeline takes about a second to get data, parse data, send data, and we don't use Drupal at all in that part of the pipeline. There are things that we use Drupal for an awful lot, and we're going to talk about that. But Drupal has a lot of baggage, even Drupal 8, that comes with it when you try to use it, right? Every time you bootstrap Drupal, even if you're caching, right? Even if you are cached to the nines, you still have a lot of technical sort of weight that comes with trying to communicate with Drupal. And I would actually argue that if you're talking about getting data out to a sign and you're trying to get the most current data out to a sign, the cache is going to bite you anyway, right? Because cache data doesn't do you any good when you're updating your data every couple of seconds. So what we really tried to do is think about how can we use Drupal in a way that Drupal's good at, right? What can we sort of, optimize its strengths for without having to worry about every time this pipeline's trying to run, use Drupal? We also wanted to think really seriously about, are there moving pieces here that we can limit how often they have to run? So we actually added an additional piece here that we call the change checker. And once we categorize data, we keep track of what the last data payload we sent was. So send data, go get new data, get it ready to go. Oh, this new data is exactly the same as the old data. There's no reason to send it again. Get out, start over. And we do this for every single sign every time we're running through this process. This actually cuts costs. The way Amazon bills their IoT service is it's like every million messages you pay a fee. That's important, but ultimately we're trying to make sure that we're not sending this more than we have to. Something that we would never have imagined, but as fast as our pipeline is, the thing that slows it down the most is actually the authentication and sending of the data to Amazon. Because we do all of our parsing and everything on bare metal, so we can do that all internally very quickly. But as we queue the data up and actually start sending it out, it takes a couple of seconds for the entire pipeline to clear through that queue out to Amazon, as opposed to like a second where we actually do all the work locally, which is interesting. And we do use Drupal here to help optimize this pipeline a bit. And I'll show you an example here this in just a moment. We have cron jobs that actually execute Drush scripts. You don't have to use Drush if you want to write your own custom, queue runner scripts. You absolutely can. But we have Drush scripts that get called by cron jobs, and then the Drush scripts execute the pipeline, and then the pipeline interacts with cached Drupal data, so that we can again use Drupal in the pipeline without it having to be a part of every run. We'll talk here in a moment about what that caching process actually looks like. But let me show you kind of what this pipeline looks like from a Drush perspective. So we have a sort of generic send data script that we can run, and we can pass in different providers to this. So we can have, say, weather run every 5 or 10 minutes. We can have the clock run once a minute. You might wonder why we're sending clock data. We want to make sure that every screen shows the same time at the same time. If we do that based on the web server time, we know we're good, as opposed to local device time, which may be off. We can send messaging data maybe once a minute, twice a minute, and then if we have like transit data, which the sign is supposed to be showing, that's where we can run that like 20 times a minute. So we have a very, very high degree of customization that we can apply to this, thanks to cron jobs and Drush. So the very first thing that this Drush script does is it sets up our logging class, because we want to make sure that, again, anytime we start looping through this data pipeline, the logger is already gathering data and sending it. We queue up our provider based on which data provider we're calling with Drush. We get our categorizer, our sender. You notice we're actually hard coding AWS here because, again, that's the only one we're using in this pipeline, but there are many services and there are many options. This guy is actually something we added in the last 6 months. As I mentioned, we discovered the hard way that communication with AWS was slowing down our pipeline quite a bit. And we set up one of their services called the command pool. So this actually lets us send out 75 things concurrently as opposed to doing them one at a time. It really makes that communication go a lot faster. We have some additional logging here if needed. This is more for local development than anything, but we do some printing to the console just so we can see what's going on. Send data. This send data to screen class, I didn't grab an example of this, but you basically pass in the provider, the sender, and the categorizer, and this is where it actually gets the data, gets everything ready to go and actually send to the screen. And then you can see here in some of our special providers, this is where we actually get the data storage and the change checker ready to go, where as we get this data ready to go to the screen, we go in and check to see if it has changed or not. Yeah, question?
So here the AWS you're using here, just use it as a push server?
So the question was, are we using AWS as a push server? Yes, but it's a little bit more than that, because it has... Using IoT, we use the MQTT messaging protocol, which has a very, very long connection time. So it allows us to have multiple devices all subscribe into what Amazon calls topics. and then we push the data up to the IoT server, and then the IoT server pushes that data on out to the signs. And it's super slick, because if you have 5 signs all subscribed to the same topic, as soon as we push data once, it's on 5 signs. So yes, it is sort of being used as a glorified push service, but because of their messaging protocols and the way they do it, we get a lot more out of it than just, pushing data out. Yeah, so, again, this is just an example of how, we sort of use a Drush script to pull all of these pieces together. And again, we do this many times a minute for some. And we don't tend to see performance issues there. Your question about AWS was timely. So let's talk about data transmission real quick, right? So if this is our current state of the pipeline, in this picture we have the sender sending data directly to the signs, and that can be really touchy, right? I mean, if you think about a normal website, typically new data only comes in when a user makes a new request, right? Somebody goes and clicks on something, refreshes the page, you get data that way. Even if you have asynchronous communication, again, Slack, Facebook Messenger, etc., you often have some sort of back and forth communication between the web server. Most people don't go to the extent of setting up like an MQTT messaging protocol for their website. And if we get back into that push and pull model, we're back into that situation of now you've got thousands of signs constantly asking for data, and we don't want that. So this is where we bring that IoT framework into play to help limit requests. Ultimately, the thing we want to make sure is that our web server is not getting thousands of requests a minute for new data, right? So IoT is the solution we've used for that. There are others that you can use, but IoT for us seemed to make the most sense based on the billions of messages that we send every month. Amazon has handled the scaling there very nicely for us. So I am the farthest thing from a front-end developer, but I do just want to take a moment and talk a little bit about some assumptions about the front end, right? So when we're looking at this pipeline, basically what this final arrow represents is here's some data. Have fun, right? The sign now has to know what to do with that data. And because we have completely backloaded all of the parsing, all of the acquisition, all of the everything into the data pipeline, that's great. But it does mean that you have to have a front end now that is ready to receive the data that you've so lovingly crafted into some sort of JSON or other data package. We worked with React, but you could certainly do this with Angular, Ember, pick your framework. And basically what the front end needs to be prepared to do is receive data, parse data perhaps a bit, and really both of those things are going to need some sort of JavaScript framework, right? I mean, I wouldn't do it with jQuery, but some modern JavaScript framework. The other thing about a custom front end is that you will really own the look and feel of that sign. If you have ADA requirements, if you have branding requirements, by going out and actually building a custom front end, you will have direct control over those things. You can also do a lot more automated testing, which we'll talk about more later. I'm not going to really get into what a decoupled solution for Drupal looks like. Dries recently did a webinar on Decouple Drupal. He talked a little bit about Signage in that, so go listen to him talk about it. He probably did a better job than I would anyway. And he also has a really great blog post about Decouple Drupal, and this is from a couple years ago, but it still rings very true. But basically, I'll just say that the advantage of decoupling is that you really are letting the JavaScript application do what it's good at, right? You're giving it data and it's reacting to that data, and by doing this, hopefully you can lower the amount of memory that the front end needs to actually operate. You can take the data payload and display it as you want it without, again, Drupal having to get into the way. And our experience is that by using a JavaScript framework for that, it's just going to happen way faster and way more seamlessly than it would with, Twig and other sort of standard Drupal technologies. You can also do a lot of really cool stuff in JavaScript from a state connection or a state situation, right? So MQTT does have a timeout on it. So every one of our signs disconnects every day, right? So that's something that the front end has to be able to do. Fault tolerance, right? Sign disconnects, sign goes, oh, hey, I just disconnected. Now it gets into a reconnect loop, reconnects, continues going. The front end has to be able to handle what happens if no data comes in, what happens if I can no longer authenticate, what happens if, what happens if my SSL certificate's invalid. There's just all of these things that you have to build into a custom application that will run in a browser. And again, doing that in a decoupled manner is, I think, much easier than trying to do it as part of your actual Signage application. Let's talk a little bit about testing. So we actually did an awful lot with Behat here. And I'm pretty proud of the testing we did on this project just because we literally execute our entire data pipeline as part of our automated tests. So we simulate data, we pass data into the pipeline, it gets parsed, categorized, it actually sends out to Amazon in the same way that real data would, and then we go and check what ended up at Amazon. So like we dump something in one end and watch it come out the other and make sure that what we think should be there is actually there. So just to show you a quick example of that. So again, this is transit data, and this is a fairly basic little Behat test, right? So we're creating routes and stations and platforms and screens, very, very basic sort of structural data. We'll talk more about that in a moment. We're running our drush commands from inside the Behat test, so we're installing this material in Drupal, and then we're telling Drupal to do stuff with it. And when it goes out and checks for like this topic on Amazon, it's actually saying, does this topic have the expected data? And we have a JSON array in our feature context that we compare with what we think should be there and what's actually there. And literally every integration build that we run, every pull request that we run, we're testing that entire data pipeline from beginning to end with every bit of code that changes. And it has caught more problems than, we knew it would catch stuff, but it catches more stuff than we could have possibly imagined. So, there's a lot of advantage to building your tests to use the exact same code. Now, we obviously had to take some precautions here. We have separate environments between production and dev so that, our horribly fake data doesn't ever end up on the same server that the production stuff is in. We have painfully obvious like local and CI and development areas so that, again, this stuff is different. We actually had to randomize some numbers so that if we had multiple builds running concurrently, a build at this process didn't clobber a build at that process because the same data was ending up in the topic. But again, working through some of those challenges is really, really worth the end result. And again, this is something we run through our Travis and pipeline builds every day just to make sure that we're not experiencing any oddities there. All right. One last slide on. We actually do quite a bit of testing in the front end as well. We're using Jest as our front end testing framework. I took our front-end architect's recommendation on that one, so I can't give you a lot of data on why we're using Jest versus, say, Mocha or Chai or others. But we are able to do an awful lot of logical and unit testing in the front end, again, to make sure that the data coming in triggers all of the business logic in the sign that we would expect. And even though we don't have our Jest tests wired up to the Behat tests that I just showed you, we're using the same example data to trigger the states in the front end. So, we're basically testing the back-end pipeline saying, does this data match up to this point? And then we use that same data and test the front end and say, okay, from that point, let's make sure that everything happens in the front end that it's supposed to. Okay, so let's talk about Drupal a little bit. So I talk a lot about structure in a signage system, and let me explain what I mean. So when you have lots and lots of signs, that means that you have lots and lots and lots of configuration for signs, right? So different signs might be different sizes. They might be different orientations. Some may be horizontal, some may be vertical, even if they are the same sign. Physical location, you may have different signs on different platforms. You may have different signs in different countries, right? Depending on where you're installing these. One of my favorites is having the same sign in the same physical location but backwards. So you have them back to back. So depending on which side you're looking at, you're facing a different direction. And then of course, different signs are going to have different IP addresses, which could have some interesting security concerns. You have to manage all this stuff. In my experience, most data pipelines are going to ultimately need some context to tell which sign gets which data. And one of the biggest disadvantages of not using a content management or some sort of management system in a data pipeline is if you go and install signs or if you go and change hardware, your data pipeline is only as accurate as your last inventory of signs. And the last thing you want to do is have to go deploy your system every time somebody installs or changes a sign. So this is, I think, one of the highest value pieces that Drupal can provide into this data pipeline. You can actually manage all of the configuration, you can manage all of your devices, you can manage everything about your signage system from within Drupal. So anytime you need to go and change an IP address, you just go edit the node in Drupal or you edit the entity in Drupal for that sign and you update it. Anytime you install a new sign or take down a sign, you go add it into Drupal, and now Drupal is managing that data for you. This is where the first caching layer can really come in and be useful. You take all this data out of Drupal into a cache, and now your pipeline can access that cache every time it runs. So again, we're not bootstrapping Drupal, but Drupal is providing 100% of the context for the categorizer class to actually figure out where to send the data. So let's talk about a couple of examples here, right? So if you have a campus, a university campus, you have a bunch of buildings on that campus, you have a bunch of signs throughout the buildings. Similarly with retail, maybe you have stores over a fairly large region, right? Maybe you have hundreds of stores across different states or even different countries. Then you have different departments within those stores, and then you ultimately have your signs. The transit example we've used now several times. You have different stations, you have different platforms, and you have different signs. What we've done is we use a lot of entity references, and we use different entity types to basically define this structure in Drupal. And at each level, whether we're talking about a specific campus, a specific building, or a specific sign, we can add context to that. Imagine putting in the address for the building. So now you could actually plot out all of your signs on a map because you know where it's physically located. The sign itself, we're tracking how big is the sign, what direction is it facing, what the IP address is. Again, we've got all that material stored in Drupal. And then we roll all that out into a cache that gets pulled into the pipeline, as I said earlier. This is, I think, the single most valuable way Drupal can contribute to this pipeline system. There is not another, all of the other technologies we've talked about, you could go build this in pure PHP and not use Drupal at all. You could build it in Node, not use Drupal at all. The thing you're going to miss in that solution is the ability to easily go in and update that structure of your signage system. And because of its API first and object-oriented nature, Drupal 8 is really ideal to be paired with those technologies to help manage this. I mean, could you do it with WordPress? I mean, sure. Should you? Probably not. The other thing that I just want to throw out there is that Drupal absolutely can fit the mold of a data provider. Right? So if we're talking about that very first box, going out and getting data, imagine if that provider is communicating with Drupal to get data. So now we have our friendly list of why do we use Drupal, right? All of the things that make Drupal so powerful, we can now feed back into that signage system. So imagine, if you will, our university example. Your communications department is going out and creating news and research highlights and pulling in all of this awesome stuff for your external website. If your data pipeline can communicate with that Drupal site, or whatever site, but let's presume it's Drupal, you can now use the same content that you're putting out externally or even on your intranet to power your signage system around campus. So all of your content authors and administrators get all of the power of Drupal, and ultimately you're reusing that content. So, again, whether this is Twitter, whether it's Drupal, whether it's some custom system, I think overall this entire data pipeline can really be enriched by Drupal. And the context provided by that structural content, I think, is really key. And I'm very excited to have worked on this project. Doing transit data with Drupal is something, like my first reaction was kind of, oh, we're going to use Drupal for that. And, a year later, I honestly, I can't imagine trying to do what we've done on this project without Drupal in the mix. So many of the challenges that we've come across, again, testing, logging, queue running, managing the structure, we've been able to go back to either Drupal itself or the Drupal community and associated technologies to solve every single one of those problems. And I think trying to do this kind of in a vacuum without Drupal and those associated technologies would have had a very different result, and probably not for the better. Okay, so I wanted to leave some time for questions, and in lieu of questions, some time for you guys to get up to lunch. So, thank you very much. Do we have any questions? Okay. Well, thank you very much. Hope you guys have a good rest of the con.